So in the beginning, I started setting up. I was wanting to learn Alexa, and Alexa is sort of based on the sort of Erlang model and system. And so I started building or sort of reconstructing cadCAD in Alexa and called it CADX. And it got, it worked fairly nicely. The API, I think, was the biggest point where I could kind of improve upon cadCAD in a way, but the performance was not great because, yeah, Alexa by itself without sort of libraries to improve calculations, and the performance is not great. But it had some basic feature parity with cadCAD, and it was a great learning experience. I then sort of carried on and started looking at Haskell, and I think Haskell is, it's being used for some smart contract programming language DSLs on a sort of higher level. I know that within Block.Science we had some interesting discussions about Haskell and its place within modeling, and this is a pretty much non-functional version of cadCAD, but also, once again, just acted as a nice learning experience for me to take a look at the Haskell programming language and category theory and apply it to generalized dynamical systems in the context of cadCAD. Another sort of work in progress one that hasn't seen the light of day is a version of cadCAD called Wasn'tCAD, which was looking at sort of WebAssembly. And the idea here was that in future, a lot of smart contract programming languages are going to, for example, eWasm, are going to be able to take assembly in some form. And in this case, it's Rust that generates assembly. And I think Parity uses Rust and WebAssembly to implement some of their smart contracts. So I thought, it could be a nice in future end-to-end workflow if you model something in cadCAD using WebAssembly and then migrate that into a smart contract directly, or more directly than you could using Python. And then when I started working on the cadCAD edu MOOC in the middle of last year, we started picking up sort of shortcomings in the cadCAD API in terms of ease, accessibility for new users. And I think, cadCAD as a tool has been incredible for the industry, and there's a lot of things that we're now learning about the API that we've already started discussing in some of the core tech calls. And so I just took that as an opportunity to start playing around in a sort of scratchpad, where I sort of started re-implementing some of the cadCAD features initially in Rust with a sort of Python wrapped in a Python package so that you could still use it from Python. But I didn't find any real benefits to implementing it in Rust. I sort of imagined performance improvements in future, but because we're still using Python for the core sort of logic, the sort of the interface between Python and Rust slows down those calculations quite a bit. So some of the goals I had with radCAD were to try and create as simple an API as possible for ease of use, try and make it performance driven. So I'll show you later how I've tried to kind of ensure the performance doesn't degrade. I wanted to make sure that it was compatible with what is now being discussed as the sort of generalized dynamical system form, which is all of your sort of standard functions, data structures, and simulation results. And I think there's actually a specification now being created for cadCAD in terms of the sort of framework rather than the reference implementation cadCAD itself. And I also wanted to make sure that it was a sort of maintainable and testable code base. I think test-driven development is very important with these sorts of tools so that you can validate that the output is correct and you can quickly make adjustments, introduce new features without being worried about breaking potentially critical systems. There's been a lot of discussion about whether cadCAD will be used as a digital twin in future for decision-making processes. And I think without a very well-tested code base, at the moment there's a coverage of sort of 88%, which can still be improved, but it's pretty good. You don't have those assurances that the system will behave as you expect. So I'll just walk through the README for a start, and then we can dig into some of the code and examples. So one of the first sort of examples that I was keen to look at is something called Game of Life. It's a very sort of nice model in that it's got 4 simple rules, and there's lots that you can go and investigate and Google yourself about the Game of Life and the original creator of this model. But the basic rule is that you have different cells. These cells interact with each other. These cells die by different sort of methods of or ways they update. So overpopulation, generation, underpopulation, and reproduction. So in the end, this kind of model looks something like this, where you've got a loop, which is implemented in a seed like this, which is a series of seed your simulation, and you can go and fetch some. Then the other one, Danilo, is a core contributor to Cad Cad, as well as a sort of expert data scientist and modeler that's in our ecosystem, and he created the predator prey, or at least he converted the predator prey model by Lotka and Volterra into Cad Cad. And because Cad Cad and radCAD models are directly compatible, it is very easy to port that over to radCAD with some minor sort of API updates, which I'll show you what the API looks like in a bit. So it's got the basic features that we'd expect from cadCAD: parameter sweeps, Monte Carlo runs. On top of that, it adds A/B tests, which are currently, I think, an alpha feature of cadCAD. So your parameter sweep would, as expected, create a sweep of these different parameters, and the Monte Carlo run simply runs the model X number of times with the stochastic process. A/B tests just allows you to run multiple simulations side by side and compare the results. And here you start to see what the API looks like. So you've got a sort of hierarchy of different classes in this model. You've got your model at the base. You've then got a simulation, which takes a model and time steps and runs. And then you pass these simulations into your experiment, which is simply a list of simulations. And then the API does get a bit more complex once you start digging into the experiment and the engine. But for a basic user, all you actually need is model and simulation. You don't even need experiment. And if anyone's familiar with the cadCAD API, you can see how this would be a little bit more approachable to a new user. So familiar data structure, simulation subsets and runs and substeps. If you do the cadCAD MOOC, you'll be familiar with this. And then as I've gone along, I've created some sort of more advanced features. And some of these features are things that were either implemented in forks of cadCAD or things that I've found useful in some of the projects I've worked on. So I've had this sort of opportunity to battle test radCAD a little bit in some of the sort of client projects that I've worked on. And yeah, some of these features you'll see used in those when I guess they're eventually open sourced. So disabling of deep copy is great for performance. We've got robust exception handling, which allows you to sort of return partial results and tracebacks if there are any issues in the simulation. You can save your results using hooks. We've got parallel processing with multiple backends. Ray is an interesting one because it allows distributed computing and remote execution in a cluster. So this is something that's still a little bit of a work in progress, but Ray is a great project to go and check out in your own time. So you can install it using pip. This is all the documentation that there is at the moment in this single README. I haven't kind of gone into too much more depth because I think if you know cadCAD, you'll know radCAD. They're fairly compatible and similar naming conventions. The only additional thing is perhaps experiment and engine. So the engine allows you to configure some more advanced features, for example, selecting how many processes you want, as well as disabling deep copy or dropping substeps during runtime in your simulation. And then something that I've started introducing as well is the idea of extensions. So for example, if community members wanted to build an extension for cadCAD or radCAD, they would then be able to say, install with certain list of extensions. So raise an extension because it's a very large dependency. You don't want to necessarily have to install this every time. And yeah, there's a sort of Python framework that is being introduced to essentially create plugins and extensions. Exception handling, I think, is incredibly useful. So for example, here you can disable raising exceptions, which means that you're guaranteed to a certain extent that the simulation will continue to the point at which it fails. When it then fails, it will return partial results to you so that you can debug why it failed, or simply say, okay, the simulation failed because of an incorrect parameter choice. You will also get a list of exceptions and tracebacks and some simulation metadata for additional debugging. And then I'm going to show you a model a little bit later that Roger, one of our community members, created, where we started talking together about hooks. And hooks, essentially, it's something that's quite common in JavaScript, where you are basically creating hooks for different points in time in the simulation. So before and after the experiment, before or after a subset, you have different context for each of these hooks, and then you can do what you want with that. So you could plug in or create additional features very easily without having to edit the code base. So an example of a hook is this one that I created called save to HDF5. That's a sort of data storage format used in sort of scientific computing. And what this allows you to do is take your experiment results at different points in time and save them to a file, so that, you know, if you're running a simulation for 6 hours, which we do sometimes do, then you can periodically get rid of those out of memory and store them on disk, so that you can make sure that at least if something crashes, if your computer crashes, runs out of resources, you've got those results saved somewhere. Mutation was something that was very critical for looking for performance. So I've done quite a lot of benchmarking in this model, or this library, to have a look at what the different options are for ensuring that there's no mutation. So for some models and simulations, you actually disable mutation or disable deep copying to improve performance. There are downsides to that you have to ensure that you program your mechanisms correctly so that you are not mutating the state outside of the generalized dynamical system framework. And then for those of you who want to give radCAD a try on an existing CAD-CAD model, there's a sort of compatibility extension called compat. And this takes your imports that you used to from cadCAD and sort of hot swaps them for radCAD. And what this will do is then existing configuration and port it into radCAD and run your simulation. And then, yeah, if you want to take, you know, a look at the actual code and development process, it's using Poetry, which is a sort of, it's a sort of, yeah, helps you with your environment management and dependency management, and has a few nice features on top of what you'd expect from pip. And then a basic sort of process here. There's a test pipeline that you have to go through and pass when creating a PR. And so this explains it a little bit. And then I'll go through the tests and benchmarking now. So this is what a basic simulation looks like with in this case, we do have experiment, but we don't actually need that. You can call the run method directly on your simulation. And then all this is doing is saying, this is probably the first test that I wrote for this project, which just makes sure that you can run a simulation and get a set of results. It doesn't even check what the results are. There are other tests that go into a little bit more detail, making sure that it's a sort of carbon copy of cadCAD's output, making sure that mutation is handled correctly, state history is handled correctly, state updates are handled correctly, and with different test cases. So we've got a predator-prey model, we've got benchmark models, and a basic model. And I think this is something that sort of needs to be adopted in, all the different reference implementations of the CAD/CAD GDS framework. These tests are most likely compatible, in fact, with CAD/CAD because of there's no change in that framework structure. There is a examples directory if you want to have a look at different examples. One of the most recent ones was created by Roger, which is a very cool model for looking at a harmonic oscillator. There's the game of life model as well as the two predator-prey models as well. So I've already shown you this, so I won't go into any more detail there. Let me have a look here. The harmonic oscillator one, I think we have to look at Jupyter Lab. I'm just going to show you this because it's, I think, quite a new model that maybe some people haven't looked at yet. I don't know if Roger's already presented it, but definitely worth taking a look in your own time. He's created a sort of gradient descent methodology with CAD/CAD to look at a physical system response. And yeah, I think it's a great model. And this is, I think, implemented in radCAD. He also implemented it in CAD/CAD, and it just kind of shows again that whatever engine you choose, the CAD/CAD framework, these models are portable. Yeah, and then these tests and benchmarks are basically passed into Travis and Run whenever you create a PR. And one of the nice things that happens as well is that it does a benchmark and checks that there's no regression in performance. So for the test, the performance test to pass, it'll basically say, okay, the radCAD simulation of choice has to be no more than 10% slower than the previous time it ran. And then the code base is fairly simple. A lot of these are, 200 lines or so at most. We've got the sort of engine and core, which are the sort of most important modules for running the actual simulations. And then we've got wrappers, which are all the different hierarchy of classes that we would expect to see, such as experiment simulation and a few other sort of utility classes. The different backends are implemented here, but then there's also the extension backends, which allow you to create your own implementations for the multi-processing methods, for example, using Ray. What else can we go into? Yeah, I think just to kind of talk about the motivation of creating radCAD, again, it was initially a sort of scratch pad to play around with these features and APIs. And I definitely think there's going to be sort of inspiration taken from this and fed back into CAD/CAD. And there's going to be lots of reference implementations. I think, things like WASM, I know there was another community member, I think Tanner was working on a WebAssembly or JavaScript and potentially WebAssembly version of CAD/CAD as well. And I think all of these sort of reference implementations, as long as they follow the CAD/CAD generalized dynamical system framework, will be a huge benefit to the community. For people wanting to run models in their browser, the JavaScript version from Tanner will be great. For people wanting sort of more advanced features until such stage that these are ported into CAD/CAD, radCAD's available. And yeah, I think the mathematics is what is important. The sort of reference implementation just allows you to create more complex experiments on top of that. Cool. I'll pass back to James. I don't know if anyone else is on the call, but otherwise, I think, if anyone's interested asynchronously and getting in touch with me and finding out more, they can definitely do that.
Great. Thank you very much, Ben, for the presentation. Are there any questions from anyone who's in the room now? I mean, you spoke a little bit about your motivations and what sort of started this process. Could you describe a little bit more what were the main sort of pain points in cadCAD that you wanted to sort of work around or overcome?
Sure. Yeah, I think the earliest sort of discussion that we actually had in the core tech calls was how we can improve the API of cadCAD. And there's is quite a number of things here which could probably be abstracted from the user. And I think that should be quite easy to do in cadCAD itself. The idea of sort of configs and config sims sometimes confuses people. I think basically just making sure that the sort of or the words and the syntax that we use are as easily understandable by people coming from different backgrounds. And then I think something else that cadCAD was developed internally at Block.Science, and as it went along, people started building on new features, and potentially the testing framework sort of fell behind a little bit. So I think improving the testing would be a good first step with CAD as well. And it's also something that I played around with here. I think the hierarchy of kind of feeds into the API in a way as well. What are your imports, how they're constructed and combined, and yeah, I think the reason that to kind of get a sort of more agile development process going with CAD, I think what we need to do is first of all get the tests going, and then it would be very easy, I think, for community members to jump in and start refactoring, adding features where necessary, and without worrying about breaking the sort of core constraints of the framework. But yeah, initially, as I said, this was for me to learn how to write Rust code. So although there is no longer any Rust in this library, because there were tests, it was actually incredibly easy to then port the Rust code into Python while ensuring that all these tests still passed. And I think the same can be said for CAD when we start doing refactors there.
So if you were to identify kind of the next steps in this dev project, what would they be? You said testing is one of
them. Next steps in sort of cad's upgrade process, or
well, in radCAD or cadCAD.
Yeah, I think the test coverage is pretty good, and I'm confident that this does what we expect it to do. I think in terms of feature parity, it's fairly complete with some sort of additional features. I would say that we've been having this discussion in the CAD core tech calls for a while about how to refactor the API to make it more accessible. I think that's become quite important for us when creating the CAD edu courses, making sure that we have an API that is, doesn't distract the user from what we're actually trying to teach, which is system modeling and that sort of engineering process. I think we all, this is an open source project, obviously, and I think it'll be very easy to port this or adopt this within the CAD-CAD ecosystem, whatever the easiest route is. Yeah, I think the CAD-CAD team have also been, working on some, I think Michael Zargham tweeted about it, they're working on a platform, which, I don't know how much detail there is out in the public about that, but, related to CAD-CAD. And so I think the core CAD-CAD team have kind of been heads down working on that. And so hopefully this will kind of feed into the refactors of CAD-CAD and ease the load a little bit.
Great, great. And if you were to make a call for collaborators for help on this, what would that be?
I think the places where it can be extended are sort of ideas about how to use hooks. So, a couple of people have already started chatting to me about different types of hooks that they could implement and how this would be useful in different workflows like machine learning, etc. This is probably the easiest place for people to create plugins. And then also, yeah, we've got a few extensions in the works as well for different execution backends. Those examples are, most of these are ported from existing CAD models with those contributors sort of listed over here. Yeah, I think that would be the next best step, is to just get people to play with the API here and suggest improvements, and also kind of get involved in the core tech calls when we discuss the CAD API, and look at radCAD, see what you like, see what you don't like, and see how we can port that over to CAD.
Great. Could you share the link here on the call just as a reference for the core tech calls, and also any other way that you'd like anyone who would want to get involved to reach out to you?
Yeah, I'll definitely share those links.
Great. Do we have any questions? Right. Well, if not, I guess that concludes the call. I don't know if you want to talk about those links now in the call as well, Ben, or you can also drop them in the link as a.
Yeah, I'd have to dig around a little bit for the core tech call link, but yeah, I can send this radCAD links along, and these other ones are not 100% operational, but people are welcome to check them out as well if they're interested in learning other languages.
Fantastic. Well, thank you very much for the great presentation, Ben. It's been amazing.
Cool. Thanks, James.
Okay. Thank you. Goodbye, everyone.
Cheers.